All right, let's get right into it. We're about to pull the rug out from under one of the most basic ideas you've ever learned, the very idea of a thing. Yeah, we're going to question the actual building blocks of our entire universe.
I mean, really think about this for a second. What if the particles that make up, well, you, me, the screen, the whole universe, what if they were never really real to begin with? What if everything that feels so solid is just a convenient illusion? Let's dive in, because your reality is so much stranger and way less certain than you probably ever imagined.
Okay, so let's talk about the comforting lie of particles. You remember high school science, right? They told us this neat little story about tiny, solid spheres, these little marbles that just click together to build the world. It's a clean, simple idea, and it's also completely, wildly wrong. So here's where things get weird. You've got two totally different ways of looking at a particle. On one hand, you have the classical view, the little billiard ball, a solid thing that follows a predictable path. Simple enough. But then there's the quantum reality, and it's not that at all. A particle isn't a thing, it's more like a cloud of probability, a wave of possibilities. And here's the real kicker. You don't just observe it, you're actually part of the equation. You participate in its reality. Okay, so how do we know this? Well, there's one experiment that just completely shatters that old-school classical view. It's called the double-slit experiment. And look, the setup is super simple, but the results, oh man, the results force us to look the true weirdness of the quantum world right in the face.
Let's walk through this, because this is the core of the mystery. Step 1. You fire something solid, like marbles, through two slits. What do you get? Two bands on the screen behind it. Makes sense, right? Step 2. You send waves, like in water, through the same slits. The waves interfere with each other, and you get this complex pattern of many bands. Okay, also makes sense. Now, for the bizarre part. You fire electrons, one by one, which we think of as tiny little particles, right? And what happens? They slowly build up that wave pattern. How? But wait, it gets even weirder. The moment you put a detector there to see which slit an electron goes through, the whole interference pattern vanishes. Poof! And you're left with just two bands, just like the marbles. It's as if the electron knew it was being watched and changed its behavior.
This right here, this is why the legendary physicist Richard Feynman said this one experiment contains the only mystery of quantum mechanics. Seriously, if you can even begin to wrap your head around this, you've understood the central, mind-bending paradox of it all. Reality itself seems to change based on whether or not we're looking at it.
So, if you thought that was strange, buckle up, because this whole probabilistic nature of particles, it leads to some even more bizarre behaviors that just completely defy all common sense.
This brings us to a concept called superposition. Now, this is crucial. It doesn't just mean we don't know where the electron is. It means the electron is literally in a ghostly blend of all its possible states at the same time. It's not here or there. It's here and there, and spinning clockwise and counterclockwise and everywhere else it could be all at once.
And then you have something called quantum tunneling. Okay, picture this. You roll a ball towards a hill, but it doesn't have enough energy to get to the top. What happens? Obviously, it rolls back down. But in the quantum world, because that particle is a wave of probability, some of that probability can actually leak through the barrier. And poof, the particle can just appear on the other side, as if it were a ghost that passed through the wall. And this isn't some sci-fi fantasy, this is real. It's literally how the sun generates energy. Okay, so let's recap. Particles aren't solid things. They're these weird waves of probability. They change their behavior when we look at them, and they can even pass through solid walls. So, if particles are just an illusion, then what is actually real? I mean, what is the universe truly made of? If the idea of a particle is just a useful story we tell ourselves, then what is the actual fundamental fabric of reality? Well, we have an answer, or at least our best answer yet. It comes from the single most successful theory in all of physics, quantum field theory. And it says the true foundation of reality, it isn't particles, it's fields. So try to picture the universe differently. It's not a box full of tiny marbles. Instead, imagine it as a vast, invisible ocean that fills all of space. And what we call a particle, say an electron, it isn't a thing floating in the ocean. It's just a temporary ripple, a little localized vibration or excitation in the ocean itself. In this case, the electron field. This is a huge shift in thinking. Particles aren't things, they're events. Okay, let's put all the pieces together. What does this all mean, really? For us, for the world that feels so solid under our feet.
Well, here's the new reality. First, matter isn't made of solid building blocks. It's just patterns of energy. Second, you ever wonder why every electron in the universe is a perfect identical clone of every other one? It's because they're all just ripples in the exact same universal electron field. Third, empty space isn't empty at all. It's this seething, bubbling ocean of potential energy. And what does that make us? Well, we aren't collections of things. We are coherent, stable patterns of energy held together for a short while in these vast quantum fields.
And that leaves us with one last, kind of heavy question to think about. If the solidity you feel is really just an illusion, and you yourself are made of these strange, probabilistic ripples in invisible fields, then what exactly are you?